The point of this study was to try to understand how limbless locomotors, which have long bodies, which can bend in interesting and complicated ways, how they manage to move through complicated terrain. We have a problem right now in that our man-made robots that are intended to act in ways like the animals act, that can move through tight spaces, confined environments, clutter, really have major problems. And we think that the kind of combination of passive mechanics and neural control that the animals use, that we hypothesize the animals use, can help us build, help our engineering colleagues build better robots. Previously, Perrin Schiebel, the PhD student who led the project, had studied how these desert animals, how they interact with the granular material that forms their habitat. And she discovered that these animals have become very specialized in how they move.
We created a setup that was a large spatially uniform substrate. In this case, we chose to use shag carpet to get around some of the experimental challenges of dealing with sand. And we put a single row of obstacles in the center of that substrate. So what I found was that the snakes, when you put them down in the arena, they will initially start moving using the same waveform that they use all the time. So as the snake passed through the obstacles, the forces that the obstacle applied to the snake's body were what caused the waveform to locally change. So the snake's body would locally buckle under the force applied by the post.
Some of the more interesting results of this study are, first of all, this beautiful pattern, this diffraction pattern that emerges from this organism's simple interaction with its environment. The next bit is that we can explain this. Perrin developed a model which explains and rationalizes this behavior in a very simple way. We had a theoretical colleague, a theoretician, Zeb Rocklin, professor in physics at Georgia Tech, who developed a theoretical model to help really get to the core of what's going on and why this snake, quote unquote, diffracts in the way it does. I also think that once we have started to think more deeply about actually where the control resides in these snakes, this can start to inspire better robots that can move in complex landscapes.